Kia ora koutou, Reese from QuickSense here, and today we are looking at identifying triangles. Now this question is asking us to look for a very specific kind of triangle, an obtuse angled triangle. So before I can even answer this question, I need to know about obtuse angles. So an obtuse angle is any angle that is greater than, so greater than, we'll write that down, 90 degrees and less than 180. So it's in between, it's all the angles in between a straight line and a right angle. So everything in between those is an obtuse. So when I'm looking at these triangles, I'm trying to find angles that satisfy that. Now immediately, I can see this is a right angle, and these angles here are both smaller than a right angle, what we call an acute angle. So it's not this one. Put a cross on that. This next triangle, right, less than 90, less than 90, less than 90. So once again, not an obtuse angle triangle. This third one, less than, but this here, right, we can see, zoom in a little bit, this is where 90 degrees would go. And we've got a little bit more in there. So therefore, let's get rid of those dots. Therefore, this angle here is an obtuse angle. So this is an obtuse angled triangle. This next one, acute, acute. Now this top angle looks to me like it's going to be a right angle triangle, but we need to look into it a little bit deeper. But for this, we can see that it is a right angle triangle. In this next question, we're given a pretty interesting diagram. So it's saying that two fixed pins are placed on a board at points A and B. So down here, so these points are stuck. And the third pin, in C, is moving along this dotted line. And as it moves along, we're making a triangle. The distance between the points A and B is equal to the distance between the line A and B. Right, that's where this X comes from. And it's asking us which of the following triangles will be formed by the elastic band as pin C moves along the dotted line. Okay, so immediately, looking down this list, I can actually already see an obtuse angled triangle, right? The one that we begin with. So I know that we can do this because it's in the diagram. Now the second one, or the first one really, I'm going to look at is the isosceles triangle. Now an isosceles triangle is a triangle where two sides are the same. So two sides I already know what one of the sides is. So an easy way to figure this out is, can another side be X? And we know that as we move C along this line until we get to this point here, or this point that is at a right angle above, this distance is going to be X. So I'm going to have an isosceles triangle that looks a little bit like this. That's X, whatever this is. So that's isosceles, but it's also a right angle triangle. Now, an equilateral triangle, that's where the three sides are the same. And so let's begin with our example where two sides are the same. Right, so we already know one side, which is X. So we're going to look at, this is what the equilateral triangle should look like, or something like this. Let's make this a little bit nicer. Where this is X, and this is X. And we also know that with equilateral triangles, each of the angles is 60 degrees to get to 180. But if we have a look here, right, these two things can't coexist. Right? I can't have this isosceles triangle with two sides that are x because this angle here, or this line here, is more than x. Right? And we also can't have three 90-degree angles because that's more than 180. So for a couple of reasons, we cannot make an equilateral triangle. So this one is not true. We can make an isosceles, an obtuse, a right-angled, but not an equilateral triangle.